Hello everyone, on today's presentation we will discuss the BIOS security. The structure of the presentation will be as shown. Definition, boot process, importance of BIOS integrity, tools, and finally, threat to the system BIOS. First, let's begin with the definition. The BIOS is the first piece of software executed on the main central processing unit, CPU, when a computer is powered on. Its primary role on modern machine is to initialize and test hardware components and load the operating system. This operation is called booting. In addition, the BIOS loads and initializes important system management functions such as power and thermal management. System BIOS is typically developed by original equipment manufacturers like Gigabyte, ASUS, MSI, and Intel. The motherboard is then bought by companies like Dell, Acer, HP. Note that BIOS implementations are specifically designed to work with a particular computer or motherboard model. To figure out what BIOS version you have, click on the Home button plus R on the Run window, type msconfig. A window like this will appear. Under the Tool tab, click on Information System and click on Run. This window contains important information. We can find the BIOS version. The BIOS is stored in the system flash memory, a non-volatile storage location of system BIOS, an electronically erasable programmable read-only memory on the motherboard. In addition to the motherboard, a given computer system can have BIOS at several other different locations. BIOS can be found on hard drive controllers, video cards, and network cards. A hard drive controller is a circuit that enables a computer to read and write information to a hard drive. Manufacturers frequently update system firmware to fix bugs, patch vulnerabilities, and support new hardware. Typically, system BIOS firmware is updated using a utility or tool that has special knowledge of the non-volatile storage component in which the BIOS is stored. The boot process governs how a system and its components are initialized and coordinate the loading of the operating system, making it one of the most fundamentally important aspects of security for any device. The code supporting the boot process is the first code executed on a system, and it's likewise some of the most privileged code, requiring protection even from privileged operating system code. As complex as it can be, this process can be divided into this simple instruction. First, executing the first code or the core root of trust. The system BIOS may include a small core block of firmware that executes first and is capable of verifying the integrity of other firmware components. In such case, BIOS and may provide mechanism for recovery if the main system BIOS firmware is corrupted. This has traditionally been called the BIOS boot block. The boot block executes the part of the most conventional BIOS and initializes most of hardware components, the power on self-test code, which leads us to the second step, initializing and test low-level hardware. During post, key low-level hardware on the computer system is initialized, including the chipset, CPU, and memory. The system BIOS initializes the video card, which may load and execute its own BIOS to initialize graphic processor and memory. Next, selecting the boot device. After system hardware has been configured, the system BIOS searches for a boot device like a hard drive, an optical drive, or a USB drive, and executes the bootloader stored on that device. Finally, loading operating system. While the system BIOS is still in control of the computer, the bootloader begins to load and initialize the operating system kernel. Once the kernel is functional, primary control of the computer system transfers from the system BIOS to the operating system. As the first code that is executed by the main CPU, the system BIOS is a critical security component of a computer system. Malicious code run at the BIOS level could have a great deal of control over a computer system. It could be used to compromise any component that are loaded later in the boot process. The system BIOS is potentially an attractive target for attack. It could be used to compromise any component that are loaded later in the boot process, including the hypervisor and the SMM code. The BIOS is stored on a non-volatile memory that persists between power cycles. Malware written into the BIOS could be used to reinfect machines even after new operating systems have been installed or hard drives replaced. Because the system BIOS runs early in the boot process with very high privileges on the machine, malware running on the BIOS level may be very difficult to detect. On a survey made by Forrester and Dell with 307 IT security risk and compliance decision makers at companies with more than 500 employees to explore this topic. This data shows how critical hardware level security is. The following questions show the different attack carried from a hardware level. On the next question, approximately more than 20% of the companies have experienced 2 hardware-level attacks in 12 months. The study had concluded that attackers had already begun breaching security at the BIOS level. Nearly 2/3 of companies have experienced a data compromise or breach within 12 months due to an exploited vulnerability in hardware level security. To better understand the technicalities of the BIOS security, it is better to understand a more abstract concept, the chain of trust. In computer science, a chain of trust is established by validating each component of hardware and software from the end entity up to the root certificate. It is intended to ensure that only trusted software and hardware can be used while still retaining computer flexibility. The computer will only boot from software that's been digitally signed. The signing authority will only cite boot programs that enforce security. This process may continue for several layers. This process results in a chain of trust. The final software can be trusted to have certain properties because if it had been illegally modified, its signatures will be invalid and the previous software will not have been executed. The previous software can be trusted because it in turn will not have been loaded if its signature had not been invalid. The trustworthiness of each layer is guaranteed by the one before, back to the trust anchor. The trust anchor is an authoritative entity for which trust is assumed and not derived. A digital signature is a mathematical scheme for verifying the authenticity of digital messages or documents. A valid digital signature verifies authentication, which means giving a recipient very strong reason to believe that the message was created by a known sender, and integrity, the message was not altered in transit. One of the most important components in hardware-level security is the TPM. The system BIOS, with the use of a trusted platform module, can verify the integrity of firmware and software executed in the boot process. A TPM is an international standard for a secure crypto processor, a dedicated microcontroller designed to secure hardware through integrated cryptographic keys. Likewise, a TPM chip is a processor that can provide additional security capabilities at the hardware level. Not all computer manufacturers employ TPM chips, but the adoption has steadily increased. If included, a TPM chip is typically found on a system motherboard. The TPM ensures that kernel mode rootkits are less likely to be able to undermine operating system security. A rootkit is a collection of computer software, typically malicious, designed to enable access to a computer or an area of its software that is not otherwise allowed. for example, to an unauthorized user, and often masks its existence or the existence of other software. It also ensures that the boot process starts from a trusted combination of hardware and software and continues until the operating system has fully booted and the applications are running. For example, the UEFI, the modern version of the BIOS, can use TPM to form a root of trust. The TPM allows secure storage and reporting of security of relevant metrics. These metrics can be used to detect changes to previous configuration and decide how to proceed. Full disk encryption. Disk encryption is a technology which protects information by converting it into unreadable code that cannot be deciphered easily by unauthorized people. The expression full disk encryption signifies that everything on the disk is encrypted, but code that starts with the operating system loading is not encrypted. Full disk encryption applications such as TrueCrypt, SecureDoc, the decrypt feature of modern Linux kernels, and the BitLocker drive encryption features of some Windows operating system can use TPM technology to protect the keys used to encrypt the computer's hard disk and provide integrity authentication for a trusted boot pathway. Another example of the use of TPM is the technology Enter Trusted Execution technology, which creates a chain of trust. It could remotely attest that a computer is using the specified hardware and software. Its main goals are attestation of the authenticity of a platform and its operating system, ensuring that an authentic operating system starts in a trusted environment, which can then be considered trusted, providing of a trusted operating system with additional security capabilities not available to an unproven one. Secure boot. Some devices implement a feature called private boot, trusted boot, or a secure boot, which will only allow signed software to run on the device, usually from the device manufacturer. This is considered a restriction unless users either have the ability to disable it or have the ability to sign the software planning to use. The user password, which is needed to start the operating system. The supervisor password restricts BIOS changes, thus making it essential to change any BIOS configuration. To know if you have a TM implementation on the run window, type tm.mcs. In my case, I don't have a TM implementation, as my computer model is rather old. There are a number of threats to the integrity of the system BIOS during the system lifetime. One of the most difficult threats to prevent is a user-initiated installation of a malicious system BIOS. User-initiated BIOS update utilities are often the primary method for updating the system BIOS. Malware could leverage weak BIOS security control or exploit vulnerabilities in the system BIOS itself to reflash or modify the system BIOS. General-purpose malicious software is unlikely to include this functionality, but a targeted attack on an organization could be directed toward an organization's standard system BIOS. The malicious BIOS can be delivered to the system either off a network or using media. Any of the preceding mechanisms could be used to roll back to an authentic but vulnerable system BIOS. A downgrade attack or a version rollback attack is an attack of a computer system or communication protocol that makes it abandon a high-quality mode of operation in favor of an older, lower quality of mode of operation. Example, intercepting web traffic and redirecting the user from the secure HTTPS version of a website to an unencrypted HTTP version. If the boot process is compromised, attackers gain control over the operating system itself and establish ongoing persistence on the device even if the operating system is reinstalled. Modern systems are intended to enable BIOS write protection to prevent the firmware from being modified. However, these protections are often not enabled or misconfigured. If the BIOS is not well protected, attackers can easily modify the firmware or even delete it completely. More broadly, anytime an actor can access control mechanism boot process, there are a number of extremely useful things that can be accomplished from the attacker's perspective. Breaking a device at the firmware level via remote malware or ransomware campaign, reinfecting a device that just been through a traditional system restore process, bypassing or disabling security control that operating system and software rely upon, such as virtualization. Rolling back important firmware and microcode updates, patching hardware flaws like CPU transit execution vulnerabilities. TrickBot is a highly modular Trojan that is particularly notable for its ability to gain administrator privileges, spread over a network, and deliver additional malware payloads. Originally defined in 2016, TrickBot was initially focused on stealing financial data and was considered a banking Trojan. However, as the malware evolved, attackers quickly found that it was a valuable enabler in all types of malware campaigns. Collaborative research between Advanced Intelligence and Eclipsium has discovered new TrickBot functionality capable of probing the BIOS firmware for nearly all Intel-based systems since 2014. The new functionality, which have dubbed TrickBot, leverage readily available tools to enable the following reconnaissance actions: identify the device platform, check the status of BIOS write protection, check for well-known vulnerabilities that can allow attackers to read, write, or raise BIOS firmware. Thus far, the TrickBot module is only performing reconnaissance and has not been seen modifying the firmware itself. As we said, updating the BIOS is a critical operation. There are a few methods like using a USB drive or updating from an exe file, but the safest way is to head to the website for UPS manufacturer like Dell, HP, or Lenovo and find the support page. Then find your specific PC by searching for the model number or serial number, which you can often find somewhere on the device. Once you have found the support page, there should be a section for downloads or drivers. Head there and search for the BIOS or UEFI updates. Download the latest one and check the instruction it came with.
So let's head into the practical part of our video, and you will discover with me how to get access to the BIOS settings and to know the difference between old and new technologies of this system, plus how we can protect it. But before we get deeply into explaining, the particularity about this important part of our computers is that we're talking about a fusion between the hardware and software at the same time. So we may have some issues to understand exactly how it works, but no worries, I will do my best to simplify it for you. In this first half of this part, I will talk about how to get access to the BIOS settings. Earlier, there was no BIOS utilities at all, so we were obliged to physically move the jumpers on the motherboard in order to change settings, but this kind of BIOS had a serious limitations, so we need a new technology to be born, so that it can handle the massive amounts of data that can be held by a hard drive or an SSD. To more clarify, the MBR, that stands for Master Boot Record, could only handle 2 terabytes of data. So for that reason, the UEFI, that stands for Unified Extensible Firmware Interface, was created, which can deal with large storage devices, and it's quicker than the conventional BIOS to boot up. And it can use a graphical interface with animations and mouse support. However, older BIOS which means mid-generation BIOS, has only featured this blue screen that you are seeing right now. So let's begin with the first method that I personally recommend for Windows 10 users. At first, type system information in the search bar. There is. Then search for the BIOS mode. There is. If it was shown as a legacy, then this first method unfortunately ain't working for you. If it's not, then follow with me the following steps. After it, you should type again recovery options in the search bar. There is. After that, you should click on the restart now button. Unfortunately, for some reasons, I can't show you the screen record of my PC, so I have chosen a video from YouTube that I will let his link down below in the description that shows clearly the following steps. So after you type the recovery options in the search bar and you click on the restart button, you should click on the troubleshoot. After it, advanced options. Then finally, a UEFI icon will show up, and with clicking on it, you can open your PC BIOS options. So let's continue with the second method. And again, for the same technical reasons, I can't show you my screen record, so I have chosen again another video that shows this second method clearly, and I will let his link also in the description down below. So if the first method didn't work for you, this one is guaranteed to work successfully on any kind of PC. First step is to restart your PC. Second step is to continue clicking on one of these buttons, delete, escape, or the F8 button, till the BIOS interface shows up. And normally the BIOS is open now. So before we start our second half of this part, you surely noticed that I'm not using the screen record option anymore, for some technical reasons again, out of my control. So I hope you would understand that. In the second half of this part, I will talk about how to secure the BIOS. As you can see right here, I have a special way, but kind of the same, to get access to my BIOS options. And that's by clicking one single time on the escape button, and then I'm allowed to enter the BIOS settings and other several things. However, as the title of the video suggests, we will focus on how to secure our PC by modifying our BIOS settings. And we mean by that, creating a password. So for me, I have a different way to get to my BIOS settings. I only have to restart my PC. So I have to press the escape button as shown right here. After it, I should press the F10 button that guide me to the BIOS setup. So I have in my PC a version of BIOS that contains a graphic interface and a mouse support, as you can see right now. We have several things. Okay, I will introduce a little bit about it. So here at the top we have the system information that guides us to some information about our PC, yeah. And to return, we should press escape, as you can see right here. Okay. After it, we can set the time and the date of the system. We're the 4th of June 2021. Okay. Let's go back, and we can enter to the system diagnosis as well. I'm sorry if the PC alert is shaking a little bit. Okay, so we're not concerned about that right now, but we can see the F1 button for system information. Startup test stands for the F2 button. The F3 button can run in the test, can do the test of run in, and the fourth button, that is the F4, is for hard disk test, if it contains viruses or not. Okay. We can also have or to restore default settings, default modes, and as well reset BIOS security to factory default as it came out from the factory to your house. And the last two steps you should do when you finish your changes, you should either ignore it if you don't want to save it, or you should press save changes and exit the startup mode. In this option, security option I'm talking about, we have two types of tools: administrator tools and user tools. The first one is a type of users that have more options than the normal user. Yes, and we can call it also as a super user. With administrator tools, we can set up a BIOS administrator password. Okay, we hit enter. We are now meant to enter a password, random password, simple. Oh, it's an error. Okay, why it is an error? Doesn't meet the password policy requirements. Okay, the password minimum length they mentioned, it's 8 characters. And yeah, the spaces aren't allowed. Yeah, the spaces between characters aren't allowed. Okay, we will reset it. Okay, we will enter a minimum password that contains 8 characters. Okay, we should re-enter it to be sure we are doing well, and type in the same password. Now we have a BIOS administrator password. After that, we have the password policy. It's not important that much, so we will ignore it. But we will head into the user management. This option gave us the possibility to create new BIOS user account that's defined by a user ID, domain, and group. To more clarify, the group contain a lot of normal users that each of them have a user ID and belongs to a certain domain. And we have also the BIOS administrator called admin, but we can't create another admin. In each PC in the world, we just have the right to create one admin, and this operation is done by the factory of your brand of your PC. So you can't create another super user. And let's jump into user tools. For the first tool is to change the password we have. So we should type the old password to change it after that. After it, we have the HP spare key enrollment. It's meant just to HP users, so we will ignore it because it's not worldwide. The anti-theft option that help us or that protect our PC to face the danger of being theft. And this option, drive lock, talking about drive lock, featured an option that is drive lock password on any restart. It shows us that we should enter a password at each restart of the PC. We should enter the password. And other utilities like the disk sanitizer, secure erase, and system IDs. I think it's very obvious, and we're not obliged to explain it. So we'll go forward and take a little look at the system configuration. We have the first option, the language. Yeah, you have the language. You can choose your language that you want. You have English, French, and other languages. And we have the boot options. Yeah, the startup menu, where you can choose what device you want to boot up your PC. If it was a floppy disk or an SD card boot or a flash drive boot. You have several options. Okay, we have device configurations. that we have here. We go a step back. After it, we built in device options. Yeah. So it's very complicated to explain it in one video. After it, we have port options, AMT options, security level. I let it by default from the factory, and I think this most secured way to protect my PC, except a few settings like that one. So we'll go a step back, and we have a BIOS power on, how you want to power on your BIOS. Resource security defaults, that I always recommend this method to secure more efficiently your PC. So that's it. We will exit right now. And the final step, if you want to save your changes, we have three choices. Yes, if you have finished your changing. No, if you don't want to save it, and exit directly. And to cancel it, if you forget to change another thing or enable another thing, so we can hit cancel and restore your options and modify it after that. So I didn't explain everything, so the time isn't enough to explain all the things we have witnessed right now in a detailed way, and I hope we met our goals, and thanks for watching.